Okay, I thought since I'm going to be out, I would go ahead and make videos of myself working the worksheets. So, I'm doing worksheet 3, evaluating limits algebraically. Okay, find each limit if it exists. If the limit does not exist, write D/N/E, or non-existent. Alright, as x goes to -4, the very first thing we always do is just plug in this value for x. As x goes to -4, the bottom is going to be a -8. The top is going to be 16 minus 4, which is 12. So this is 12 over -8. Nothing funny going on. No 0 over 0. No 0 in the bottom. This is just a -3/2. So nothing very interesting about that. It's just that's what it is. Okay? Goodness, what did I do here? 16 minus 4 is, okay. I don't know what I did there. I think I made a mistake in my key, but this is correct. Okay. Alright, 5 pi over 3. Well, cosine of 5 pi over 3 is not 0, so I know that I'm just going to get a number here. I always do the bottom first, by the way, because if I get 0 there, then something funny, something interesting is happening. Okay? So, but when I do that, cosine of 5 pi over 3 is just a half. Tangent of 5 pi over 3 is a negative square root of 3. So if I multiply top and bottom by a 2, I get -2 square root of 3. And that's just it. Okay? Number 3. Okay? If I put a 5 in for x, the bottom is not 0, so I know I'm just going to get a 2 down there. The absolute value of 7 is 7. This is just 7/2. That's all there is to it. It's a lot of space for not a whole lot of work. Okay. Number 4. Put 4 in for x. If I put 4 in for x, I do get a 0 on the bottom. So I know that, unlike those first 3, something funny is happening here. Okay? Because we cannot have 0 in the bottom. If I put a 4 up on top, I get 16 minus 16, which is 0. I have 0 over 0, which means there's a hole. I need to eliminate that hole. And to eliminate this hole, I'm going to factor. The top factors into x plus 4, x minus 4. The bottom is x minus 4. The x minus 4's reduce because x is not equal to 4. We can reduce those. So I get the limit as x approaches 4 of just the x plus 4. Put 4 into x now, and we get 8. So this work that I showed, until you are able to plug in that 4 and not get a 0 on the bottom, you have got to keep writing limit. Okay? Not optional. We have to keep writing it until you go ahead and plug it in. X is approaching 3. Well, on the bottom, I see I'm going to have a 0. Okay? Up on the top, I'm kind of assuming this is going to be a 0. 3 times 18 is 54. 54 minus 54 is a 0. So once again, we have 0 over 0. So I'm going to factor. I'm going to begin by taking out a 6x from the top. 6x. So I'm going to be left with a 3 minus x divided by x plus 3, x minus 3. Okay, these reduce. However, they do not reduce to 1. These reduced to 1. These reduce to a -1 because it's 3 minus x and x minus 3. So they reduce to a -1. Now I'm putting 3 into my remaining x's, and I have 18 times -1 divided by 6, so this is -3. Number 6. Put 1 in for x. 1 plus 5 minus 6 is 0. 0 on the bottom. 3 plus 2 is 5, minus 5 is 0, 0 on top. So there's a hole. We have to eliminate the hole. keep writing limit until you can plug in and not get 0 on the bottom. So I'm going to factor 3x and x. Okay, and let's see, I'll need a 5 here and a 1 there. I'll need a plus here and a minus there. Over x and x, 6 and 1, plus and minus. The x minus 1's reduce out. Because x is not 1, we can reduce those. I put 1 into the remaining x's, and I get 8 over 7, 8/7. Okay, it's a little bit blurry. Let me see if I can clean that up. Okay, well, a little bit better. Put 4 in for x. I always go to the bottom first. 64 minus 64 is 0. Up on top, you definitely get a 0 there. Okay, so we're going to factor to eliminate that hole. There's a hole. We're going to eliminate the hole. Okay, difference of cubes factors into x minus 4. Cube root, keep the sign, and then square of the first. Those are the two things that get multiplied together to get that x cubed. Take the product, but change the sign. Plus 4x. Product, change the sign. And then at the back, it's the square of the last term. And it's always positive. When you multiply negative 4 times positive 16, you get that negative 64. Okay. The x minus 4's reduce out because x cannot be 4, and they do totally reduce out to a 1. Plug in 4 for the remaining x's, and you get 1 over 16 plus 16 plus 16, which is 1 over 48. Okay, plug negative 4 in for this x, and we get negative 64 plus 64, that's a 0. Negative 4 in for this x, that's also going to be a 0. 0 over 0, there's a hole. We have to eliminate the hole. So I'm going to factor again. I'm going to take out a 2 from the top. From the bottom, I have a sum of cubes. Okay, cube root, square the x, the product, but the opposite sign, and then square the last. The x plus 4's reduce out. They reduce to 1, and that's fine because x is not equal to negative 4. Well, that's fine. Up on top we have a 2. On the bottom we have 16 plus 16 plus 16. That is 2 over 48, which is 1 over 24. Number 9. Put 5 in for x. 125 minus 125 is 0. 25 minus 20 minus 5 is also a 0. 0 over 0, there's a hole. We have to eliminate the hole. We can factor to eliminate this hole. Up on top, we factor into two binomials, 5 and 1, minus and plus. On the bottom, that factors into x minus 5, cube root, keep your sign, and then the square of this. When you multiply those, you'll get the x cubed. The product, but the opposite sign, and then the square of the last. When you multiply negative 5 times 25, you get that negative 125. Okay? Negative 5 times 25 is negative 125. Alright, the x minus 5's reduce out. They reduce to 1. And we can do that because x is not 5. Plug 5 into the remaining x's, and we get 6 over 25 plus 25 plus 25. 6 over 75 is that limit. Alrighty, number 10. for number 10, if I plug 3 in for x, in the bottom I do get a 0. So we have 0 on the bottom. If I put a 3 in here, I have a third minus a third, which is also 0. So once again, we have a hole. We have to get rid of the hole. To get rid of the hole in this place, in this case, I mean, I'm not going to factor. I'm going to multiply top and bottom by the product of the little denominators. The product of the little denominators. Okay, 1 over x times 3x is 3, minus 1 over 3 times 3x is x, over, don't multiply this out. Okay, we have a 3 minus x on top and x minus 3 on the bottom. Those reduce, but not to 1, they reduce to a negative 1. Plug in 3 to the remaining x, and we get negative 1 over 9. Number 11. If I put 0 in for x, I have 0 in the denominator. I have 1 minus 1, 0 in the numerator. I'm going to multiply by the only little denominator over itself. So we get the limit as x goes to 0 of, okay, 1 over x plus 1 times x plus 1 is 1, minus 1 times x plus 1 is x plus 1. Be careful with your parentheses because of the minus there. You're going to have to distribute that. Don't distribute the bottom because we want to reduce. This is already in factored form. Don't multiply it out. If you do, you'll have to factor it. So we have, up on top, we have 1 minus x minus 1. That is, up on top, that is just a negative x, right? Now these x's reduce out, and we can do that because x cannot be 0. We're left with a negative 1 on top over 1 on the bottom, so this is a negative 1. Negative 1. Number 12. If I put a 2 in for the x, I get 0 on the bottom. I get 3 over 3 minus 4 over 4, that is a 0 on top. I'm going to multiply by the product of the little denominators, x plus 1 times x plus 2. Oops. Okay. So 3 over x plus 1 reduces with the x plus 1. And I'm left with 3 times the x plus 2 minus 4 times the x plus 2 is reduced out, and I'm left with the x plus 1 over, now, don't distribute. Leave it. Leave it factored. Factored is good. Okay. I'm going to clean up the top. 3x plus 6 minus 4x minus 4 okay, 3x minus 4x is negative x, 6 minus 4 is plus 2, this is negative x plus 2. Negative x plus 2 is the same as 2 minus x. That reduces with this and leaves a negative 1. Now I'm going to put 2 into the remaining x. I have negative 1 over 3 times 4, negative 1/12. Number 13. Put negative 3 in for x. Get 0 on the bottom. 1 minus 1 is 0 on top. So 0 over 0. So I'm going to multiply top and bottom by the little denominator, x plus 4. Okay. Alright, 1 over x plus 4 times x plus 4 is 1. Minus 1 times x plus 4. Watch your signs there. x plus 3, x plus 4. I'm looking at this. Okay, so limit 1 minus x minus 4 okay, this is negative x minus 3. I'm going to factor a negative 1 out of that. Negative x plus 3. Now I can finally reduce those x plus 3's, and I can do that because x cannot be negative 3. I'm left with negative 1 over, I'm putting negative 3 in for this, so this is negative 1. Number 14. Put 0 in for x. I get 0 on the bottom. 2 minus 2 is 0 on top. Multiply top and bottom by x plus 1, 2 minus x. Okay, limit x goes to 0. 2 over x plus 1 times x plus 1 leaves me a 2 times the 2 minus x. Minus 4 times the 2 minus x's cancel, and I'm left with the x plus 1, divided by, on the bottom, x times x plus 1 times 2 minus x. I do not distribute that. Clean up the top. 4 minus 2x minus 4x minus 4. The 4 minus the 4 cancel each other out. I'm left with a negative 6x. That's a negative 6x. Now I can reduce those x's because x cannot be 0. Plug in 0 to the remaining x's and we get negative 6 on top, and we have 1 times 2 on the bottom, so this is a negative 3. Okay, number 15. Plug in 2, get 0 on the bottom. I get 0 on top. There's a hole. We have to eliminate the hole. To eliminate the hole in this case, I'm going to multiply top and bottom by a conjugate. Keep your square root. Don't change your square root. Only change that middle sign there. Okay. X is approaching 2. Multiply your square roots. The middle term will zero out. Minus 9. Do not multiply the denominator in this case. Okay, this is an x minus 2, and it reduces with this x minus 2 because x is not 2, leaving a 1 up on top. Plug in 2 to the remaining x's. The square root of 9 is 3, so this is 1/6. Number 16. Number 16. Alright, put 3 in for x. I get 0 on the bottom. 19 minus 3 is 16. Square root of 16 is 4. Minus 4 is 0. There's a hole because we got 0 over 0. And we have to eliminate the hole. So to do that, I'm going to multiply top and bottom by the conjugate of that square root expression. So leave your square root. Change the middle sign. Okay, on the top, I've got 19 minus x minus 16. The middle term zeroes out. Over 3 minus x times the square root of 19 minus x plus 4. Okay, up on top I've got 3 minus x. They reduce out completely. They reduce to 1 because x cannot be 3. We can do that. Plug in 3 to the remaining x, and we have the square root of 16 plus 4, and that is 1/8. Okay. Next up, put 0 in for x. We have 0 on the bottom, we have 0 on top. There's a hole. We have to eliminate the hole. To eliminate the hole, I'm going to multiply top and bottom by the conjugate of wherever my square roots are. Okay. Square root of x plus 2 times square root of x plus 2 is x plus 2 minus, the middle term zeroes out, minus 2. Okay, these are 0. The x is reduced to 1. Plug in 0 for your remaining x, and you get 1 over square root of 2 plus square root of 2. That is 1 over 2 square root of 2. Multiply to clean it up. For a multiple choice, we would be needing to clean that up. So that would be the square root of 2 over 4. Next up, x is approaching pi. Sine of pi is 0. Cosine of pi is -1. We have 0 over 0. That means we have a hole. So to get rid of the hole, I'm going to multiply top and bottom by the conjugate of that top. And I get the limit as x approaches pi of 1, the middle term zeroes out, minus cosine squared x divided by sine x times 1 minus cosine x. Okay, the Pythagorean identity with sine and cosine. Sine squared x plus cosine squared x is equal to 1. If I move this positive cosine squared to the other side, it'll be 1 minus cosine squared, and that's equal to sine squared. So that is sine squared x. One of those sine squareds reduces with the sign on the bottom, and I'm left with limit as x approaches pi of sine x over 1 minus cosine x. Now I put pi in for x. Sine of pi is 0. Cosine of pi is -1. That is 0 over 2, which is 0.